Woohoo! Welcome back. We are talking about 0.4, which is all about radicals and rational exponents. And we are now on number 4, which is firmly in the rational exponents category. And we're going to go ahead and start off with this one, 64 raised to the 3/2 power. So it's 64 with 3/2 as an exponent. And so, as I mentioned in the last video, officially, we're supposed to take 64, raise it to the 3rd power, and then take the square root. So this 2 right here, right there, I don't know if you can see the yellow, is the reason that we have the square root there. And the 3, which is up top in the numerator, is that 3 that's right there. So we've got these two things going on, and the problem is 64 cubed is kind of a pain. And although I have a calculator, it would be a lot easier if I didn't have to cube 64. So what I said in the last video was that, in fact, as long as everything's positive, I am absolutely allowed to reverse the order. So in other words, I take the square root, or the principal or positive square root, radical 64, and then I cube it. So what this looks like is the square root, or the principal or positive square root of 64, which is 8, cubed. And then you need to know what 8 cubed is, but you don't have to. Look at me having found my calculator. Woo! It went on walkabout, but it's back now. Oops. And now it's overly fond of the ring light. Let me turn this a little bit sideways so I don't. There we go. And so in order to calculate 8 cubed on this particular calculator, I've got 8. And then right here, I don't know if you can see. Let me see if I can get it nice and close. On the TI-36X Pro, it just says X to the box. So you click on this and see, you get that same kind of rooftop caret, that symbol that's above the 6 on a keyboard. And then I do 3, enter, and I get 512. Woohoo! Which is 8 cubed. So 512, yay! Okay, next one. Dun dun dun! So what I've done with the next one is I've asked, well, what happens if I put a minus out in front? And what we've learned in previous videos or in previous math classes is that that minus out in front only changes the sign. So basically, remember, the minus doesn't get invited to the party unless it is explicitly put inside parentheses. So since there are no parentheses, the minus is left out. It's very sad for the minus, actually. So be kind when you see that minus, because they've been through it today, you know, they don't get invited to anything hardly. So that minus just hangs out and waits for 64 to go do whatever it's going to do. And then it comes back. Now we know from here, 64 raised to the 3/2 power is 512. And the minus just waits outside. So we get negative 512. 512 is from the previous problem. Woohoo! So if we've got a minus just sitting out in front, then the minus just sits out in front. And so I hear you all clamoring, clamor, 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 clamor. You're all like, oh, please tell us what happens if the minus is invited to the party. And I'm like, I figured you would ask me that question. So this is the shenanigans that ensue when you invite minus to the party. And let me tell you, inviting minus to the party sure makes the party more exciting, that's for sure. The thing is now we've got negative 64. And we're going to try to raise it to the power 3/2. So what we're going to have here is we're going to have the square root of negative 64, because now those parentheses are keeping the minus and the 64 together. They have to go everywhere together. We've got the square root of negative 64 cubed. Now, In the previous video, when I said you're always allowed to reverse the order of the radical and the power, that only works if everything exists. So whenever you end up with something that's negative, you got to tread very, very carefully. So rather than following the shortcut, I'm going to go ahead and do this, by the books. So let me see if I can avoid. Oh, look, that's really weird. The calculator is reflecting itself. It's kind of calculatorception right now. Okay, so I'm going to go ahead and cube negative 64 because it gives me a chance to point out that whenever you're working with a negative number, I know this is all shiny, so it's kind of hard to see. You don't use the minus that's right here. You use, on this calculator, it's down here in parentheses. It's usually down near the bottom somewhere. That's a negative sign. That's a minus sign. And a calculator sees them as really different. Humans are able to understand how they're related, but calculators see them as completely different. Do not use the minus sign for a negative. So I'm going to do negative 64. And I know on some calculators, you will need to type in the 64 and then the negative sign. If you have any questions about that, ask me, send me a picture of your calculator. I can help you work out the steps. So I've got negative 64, and I want to raise that. And you know what? I'm not sure about how this calculator works, so I'm going to change what I'm doing. Let me clear. I just want to be very, very clear for my calculator, because I'm not sure some calculators do different things with their order of operations. So negative 64 in parentheses, and I'm going to raise that to the third power. And because it's negative, oh man, that is really large. Because it's negative and it's raised to the third power, it's going to stay negative. See how it's still negative? So I get negative 262,144. Man, that's a big number. Now, what's going on? Well, we're trying to get radical negative 262,144, or the square root, or the principal square root, or the positive square root of negative 262,144, which, honestly, there are two ways of looking at this. In our class, this particular class, we are not going to deal with imaginary numbers. So we're going to say this is undefined. But you may actually know that this is, let me remember, what is this going to be? This is actually going to be, hopefully I'm doing this correctly. I believe it's going to be 512i. Now, I know not everyone has studied imaginary numbers at this point, so if you're coming to this class without having any idea what the I is, don't worry about it. We're not going to do this in this class. This is a different set of numbers that allow for square roots of negative numbers. This can be really useful in a lot of settings, but when we're talking about money, finance, economics, generally, I could make a really bad dad joke about how that all those numbers are imaginary. But in reality, for us, we're going to just say anytime we get a square root of a negative number, it's going to be undefined. We're not going to worry about imaginary numbers. And I will put in another plug because I do it every video. If you want to know more about imaginary numbers, if you're curious, if you want a refresher because you studied it in the past and you can't remember it, please feel free. Drop in during my office hours, message me, email me, go talk to the tutors. We're all really happy to, spread a little math love, help you understand whatever it is you're curious about, because this stuff can be really cool, even though in this class we're not going to study it. Okay, let us move on. So, dun dun dun. Now in the next problem, I know I've got Square Bear just kind of hanging out just in case we need him. In the next problem, we've got all the same elements, just kind of written in a different order. So here I've got negative 64 raised to the 3/2 power. This is 64, positive 64, raised to the negative 3/2 power. So what we need to do here is we need to remember what that means. And I'll remind you, a negative exponent means you're in the wrong place. So in reality, we have 64 in the denominator raised to the 3 halves power. That negative on the exponent means it's in the denominator. Notice the negative on the 64 does not do that. So minus signs in different places cause completely different situations. This is a negative base, leads to it being undefined in this case. A negative exponent merely means you're in the denominator. But once you're in the denominator, then we can say, wait a minute, right back here, we already figured out that 64 to the 3 halves is 512. So this is going to be 1 over 512. This is from number 4. And then we're done. So all it's saying is, what if it's a negative exponent? And that just means it's in the denominator. So again, there are going to be a lot of little details to remember. And, you know, please, if this is not feeling like you've ever seen it before, you don't remember it, this is like, what's even going on? Come talk to me, talk to tutors. We would love to help this make sense. And it makes sense to make sure you've got this sorted before we go on to some stuff that's even more complicated. Okay, now, number 8. This is very, very exciting. What's going on here? Negative 64 to the negative 3 halves. So now I've just thrown in all the minuses, all the negative signs. So what I'm going to do, in addition to rewriting it, just to make sure I understand what's going on, is first I'm going to approach the structural aspect. So I look at that negative exponent and say, oh, okay, this means I've got negative 64 raised to the 3 halves in the denominator. Okay, so the negative in the exponent means we're in the denominator. But again, I have got a problem right here that says whenever we've got a negative 64 raised to the 3 halves, that ultimately that's going to cause something to be undefined because we're going to get a negative inside that square root. So if it's undefined when it's up on top, it's still undefined when it's in the denominator. So this problem is still undefined, just in the denominator now. This is undefined. And whenever something is undefined, which just means that we haven't expressed what it's equal to. So in other words, in our setting, we're not coming up with answers for this, even though we know that it has something to do with that imaginary number I. So I'm going to say this whole thing is undefined. We're trying to take the square root of a negative number, and we can't do that in this class. We're not using that system of numbers. Okay, so we're going to abandon that, and we're going to move into fraction palooza. And again, these are just little math snacks to help jog your memory about all the math you've learned in the past, just to make sure that you feel comfortable with it. Because starting right around chapter 5, but mostly in chapter 6, we're going to be doing very complicated formulas that are going to involve a lot of exponents. And we want to make sure that you feel comfortable with the exponents before we introduce some of those formulas. Oh man, this is fraction palooza. There's a fraction here, there's a fraction there, it's fractions everywhere. So what in the heck do we do? Well, the first thing that we notice, thank goodness there are no minuses. So we don't have to worry about anybody having to move around or anything. I'm going to go ahead and start approaching this. I'm going to rewrite it, which you don't have to do. And then I'm going to take advantage of the fact that when I have a fraction raised to an exponent, that means I have the numerator raised to that exponent and the denominator raised to that exponent. I give out that exponent to the top and the bottom. Okay. Next up, I realize everything's positive. Oh my goodness, isn't that awesome? So that means I can choose whether the 3 or the 2 comes first. So remember that normally it would be 9 cubed and then the square root of that. Oops, unless I didn't leave enough room. Same thing down the bottom, 4 cubed, and the square root of that. But I can also look at it as the square root of 9 cubed and the square root of 4 cubed. Remember, we've got that option to take the power first or the root or the radical first. I think this one's easier. Personally, you're welcome to do it this way too. Both will work. They'll both give you the right answer. So I'm going to look at this and I'm going to say, okay, the square root of 9 or the principal or positive square root of 9 is 3. And the square root of 4 is 2. 3 cubed is, I know it's easy. My brain wants it to be 9. It's not 9. It's 3 times 3 times 3, which is 27. And 2 cubed is 2 times 2 times 2, which is 8. Now, I want to take a moment because we've got a lot of fractions and a lot of people, a lot of brains are just going, what even is going on there? And I know it's really easy to check out when you see so much. And it's just like, why would you even do that? And the answer is we're going to do it a lot. We're going to do it a lot when you're dealing with finance because some of the formulas are really complex. So let's make sure we take a look at what's going on. So 3 halves as an exponent. It's between 2 halves, which would be 1. So 9/4 to the 1 would just be 9/4. 9/4 squared would be 9 squared over 4 squared, which would be 81 over 16. But 3 halves is right in the middle of that. It's like 1.5. You don't just leave it just as 9/4, but we don't go as far as squaring. So let's take a look. We went from 9/4 to 27/8. So we made each one a little bit smaller first and then bigger. Did we go all the way to 81 with 9? No. Did we go all the way to 16 with 4? No, we went partway there. So that's what 3 halves represents in this case. Hopefully that made sense. If it didn't, that's okay. But hopefully one of these methods does help you to get to the end of this problem. Fingers crossed. Okay, are you ready for the last problem? Dun, dun, dun! Now, number 10, all I've done is I've made that exponent negative. I'm going to pretend 9 didn't exist so that we could practice working through this again. If you are clever, you'll look at this and you go, wait a minute. Negative 3 halves means I just flip everything over. So it means that, I shouldn't have put that away, it means that I just take this answer and I turn it upside down. So I get 8 on top and 27 on the bottom. And if that made sense, then you're done with this problem. And you can turn off the video. Woo, you finished, yay! I'm going to go ahead and I'm going to solve this as if we hadn't seen number 9 at all, just to give us some practice. So I know, here's Square Bear. He looks a little scary, but he's really just saying, yay, you can do it. He's here as our support carnivore. So, again, I'm going to write this big, because that is what I do. And then I'm going to say, okay, whenever I've got a fraction with an exponent, I can give out the exponent to the top, the numerator, and the bottom. And I don't need to include these parentheses, but sometimes people find them helpful. It helps your eyes sort out what's going on. So I've got 9 on top, 4 on the bottom. Each of them gets their own exponent. So what is this telling me? Well, this is telling me that 9 is really unhappy being up there. It doesn't want to be on top. It wants to be on the bottom. And 4, with its negative exponent, does not want to be down there either. It wants to be on top. So what I'm going to do is I'm going to move them. I'm going to move the 9 to the bottom and the 4 to the top. And in doing that, I make them happy again. Right? So the negative exponent basically means you're in the wrong place. So the 4 is going to head up and the 9 is going to head down. So basically, I switched them, but in doing so, notice that the exponents become positive. I used up the power of the negative sign there. I fixed that, so now they're happy, they're positive. And now each of them has to go through that process of being cubed and square rooted. So I've got 4 cubed with a square root all over 9 cubed with a square root. And remember, we said if everybody's positive, which once I fix this, everybody's positive, there's no minus signs, I'm also allowed to do it the other way, reverse it. Take the square root of 4 and then cube it. Same thing, square root of 9 and then cube it. So what does this look like? Well, since I have a little bit of space, I'm going to work them both out. So for this side, I've got 4 cubed, which I happen to know is 64 inside a square root. And then I've got 9 cubed. Now 9 cubed is a little bit tricky, right? It's 9 times 9, which is 81, times 9, which I happen to have memorized because I've memorized my cubes, not just my squares. And so that is going to be 729. However, as someone who does have a tendency, sorry about the ring light, has a tendency to, make mistakes with my numbers, I can double check. 9 raised to the 3rd power is 729. Yay! Okay. And then I would take the square root of 64, by which I mean the positive square root of 64, which is 8. And then I need to take the square root of 729. Now I could go ahead and use it. I'm just going to retype it in. So square root for my calculator here, let me see if I can get this really close, is right there. Let me use the pen tip. It's right there. It's above the x squared key. So what I'm going to do, I always clear out. You don't have to, but I feel that I personally like it better. Since I'm trying to get to this little guy that's in blue up on top, I'm going to go up here to the 2nd key. I click on the 2nd key, see how it tells me I'm in 2nd, and then the x squared, and it gives me a square root. I'm going to take the square root of 729, close the parenthesis, hit enter, and I get 27. Woohoo! So this is 27 down here. Okay, what's the other method? Well, the other method was instead of cubing, making them bigger, and then making it smaller, I start with the square roots first. So here I've got the square root of 4 is 2, and I've got to cube that. And the square root of 9, which is 3, and I've got to cube that. 2 cubed is 8. 3 cubed is 27. I personally think this method is easier because you make it smaller and then bigger rather than getting into these numbers like 729, which I don't have memorized. So I would always encourage you to go this way, but notice, same answer. Does not matter which one you choose. Woohoo! Congratulations, you've made it to the end of yet another math video. Woohoo! You're amazing and awesome. And remember to go get some water, get some oxygen, some exercise, eat some vegetables, maybe do some more math, make some art, all those wonderful things that keeps your brain happy and your body strong. And I will see you in the very next video. Woohoo and math on.